Hello everyone, this is Tony, the tutor with AIM, coming at you guys with another video. This is a pretty important topic that I see a lot of kids missing, especially my Algebra 1 and pre-algebra students when it comes to graphing. It's called equation manipulation. So changing the problem by using inverse operations to solve for a number variable or another equation. Now this is the first step, like I said before, in graphing. So because the probably whole second half or second semester of Algebra 1 is graphing, it's really hard for a lot of students to advance without mastering this skill. So first of all, the first step in equation manipulation is knowing or isolating the variable in question. So for example, if you're doing, let's say you're doing a graphing problem and you need to solve for your y equals mx plus b form. This is how you want your problem to look, where m is your slope and the point 0b is your y-intercept. So because a lot of students don't know how to solve, it's not that students don't know how to solve for a graph or a graph once they get here. It's just they don't know how to get here. So what we're going to do is we're going to focus on isolating variables so that they can grasp the concept and they can get here. So we're going to start with a very basic overview of some inverse operations. So here in a one-step problem, we're going to give the example of x minus 5 is equal to 6. So this is a one-step variable isolation problem where you have to solve for a variable by isolating it. And your answer will be a number. So your operation that's being done to get your answer is subtraction. So the inverse operation of subtraction, likewise, is addition. So you know, in order to solve for your variable that you're isolating in question, solve for the variable in question that you're isolating, in order to isolate it, you would have to do the inverse operation that is being done to it. So here, because subtraction is being done to my x, I must add in order to isolate it from the operation being done. So here I have x minus 5 is equal to 6. My inverse operation being addition, now I add 5. To both sides of my dotted line or equal sign. And I always line up whichever parts I'm canceling so they don't get mixed up with other parts of the problem and there isn't conjunction. So now x minus 5 plus 5 is equal to 0. So you just have an x here. We're going to take that out. And now you have 6 plus 5 is equal to 11. This is done because you know in order for an equation or a problem to remain equal, whatever you do to one side of your equal sign, you have to do to the other. So whatever is done to one side of the equal sign has to be done to the other to keep consistency in your problem. So here, this one's done. So we'll go into another example of multiplication and division. So that one's fairly simple. I'm not going to do an addition to subtraction one, but I will do the reverses between multiplication and division because they are slightly more complicated. So now we have the example 3x is equal to 9. So now this one is fairly simple for students who have been through variable isolation, but to some that haven't, we're going to work with it. So what's being done to my variable is it's being multiplied. And for students who have a hard time conceptualizing coefficients attached to their variable, it would be a good practice to remove them, to show the step so that you can physically see it's 3 times x. When you say 3x, it represents 3 times x. So that's a step that I encourage some of my students to take. But here we get into it. So what's being done to my x is the step of multiplication. So my inverse of multiplication, of course, would be division. So we're going to rewrite it as the step 3 times x is equal to 9. And now because I have to do whatever I do to one side of my equation, I have to do to the other, I would divide by 3. So that now cancels this. And now I have 9 divided by 3, which is 3. So parents, if you could, or other tutors who may be looking at this video, encourage students to separate problems completely so that they can see every step. It's very important for students to conceptualize that this is 3 times x, and 3x is not just a quantity or some number or variable that they're supposed to be solving for. A lot of students get confused when they see this 3 attached to this x because they don't understand that it's being represented as a multiplication step. So here's, if we get into a division problem, if we just flip this one and we say x divided by 3 is equal to 9. So now my variable in question, the operation being done to it is division. So now I will have to inverse into multiplication. So now I would say x over 3 times 3 is equal to 9 times 3. Because whatever I do on one side of my equation, I have to do to the other. These cancel. I have x is equal to 9 times 3 is 27. So those are just some quick examples of some one-step equation manipulation and variable isolation. Now, of course, these can be used in conjunction to form the same problem where you have to solve for a variable or a number or a whole nother equation. So you would have, let's take the example where we get into a two-step one where there are two operations that need to be done. So we would go 2x minus 4 is equal to 6. So here we notice there are two operations that need to be done. So which operation would I do first? So when you do variable isolation, you always want to do the most simple operation first. So addition and subtraction are your two most simple operations in mathematics. So you always look to do those first when it comes to isolating the variable. So because there's a subtraction step being done here to my variable, the quantity of 2x minus 4 is equal to 6. There's being a subtraction step being done. So I must do addition. So here I go. 2x minus 4 is equal to 6 plus 4. Keep them consistent with whatever you're adding and whatever you're subtracting. You don't want to put the 4 over here and get it confused into the 2x. You want to keep it consistent so that you can isolate them and knock out the problem and knock out the numbers that you don't need as you go. So I did both sides of my dotted line. So now I have 2x, this is 0, is equal to 10. Now there's still an operation being done to my x here, and I have, of course, an integer here. So my operation being done is multiplication. So of course, division is my inverse operation. And now I have 2x divided by 2 is equal to 10 divided by 2, x equals 5. So those were just some quick examples of some one-step and two-step isolating single variable problems. I will be posting another video about two-step and two-variable equation manipulation problems. You guys stay tuned, and thank you for joining and tuning in to another episode of the Math Script. This is Tony the Tutor with AIM, signing out.